Yeah, solving the passkey problem with passkeys. So first of all, who am I? My name's Hugh. I'm a developer at Hatch, like Jordan said. I worked on our passkey implementation. That's kind of my sole qualification for doing this talk, except the guy who created the original spike for our passkey implementation is sitting down over there. So he planted the seed and I germinated it, I suppose. But I worked for wider FNZ before that, so was using C# in that role, and then probably before then I knew JavaScript the best. So if you see any substandard Ruby code, and yeah, there's probably a lot better Ruby developers in here than me, that's my GitHub, that's my blue sky. When I do post on there, it will mostly be tech, but I barely ever post on there. Cool, I'm gonna start with some story time, not just because I have a 1-year-old at home. So this is Mark. The year is 1999 and he's signing up for his first web service which needs a username and password, and he thinks, oh, I've got a dog called Spot. So he goes with the 4-letter word Spot, all lowercase as his password. What could possibly go wrong? He gets brute forced. Okay, so short passwords are easy to brute force. You can get computers to make random attempts at passwords, and if you have a botnet, then you can do it from a whole bunch of IP addresses, and it's incredibly hard to block all the IP addresses where it's coming from. So he gets hacked, and he says, oh, I've got a solution. I'll lengthen my password out a bit. I'll append my date of birth, 1983, to my password. Boom, that should solve all password problems for the rest of his life. His password gets guessed. Now, this isn't the AI talk today, but there might be some AI generated art, but you wouldn't know. So passwords related to personal information about yourself are guessable. So he can't use Spot 1983 anymore. He updates his password to be a random collection of words. He's doing well, but now it's, I don't know, it's 2006 or something, and he's got a whole bunch more web services that he uses. He's got Gmail and Facebook and a whole bunch of things. He reuses the same password every time, because how else are you going to remember a random collection of words? He gets an email. Dear Mark, please pay your parking fine of $150. This will accrue interest at a rate of 10% per month. You're currently 3 months overdue. Please go to nzgov.paymyparkingticket.ru to pay this fine now. That's for the more observant of you in this room. You might notice that that is not actually a legitimate New Zealand government domain there. But he gets stressed out by the start of the email and clicks it and enters in his shared username and password, and he obviously gets phished. So now the phishers can get into any other services that he shares the password with. But he's got a solution. He's going to carefully check the URL of any email he gets, and he won't click any random links, and also his workplace has helped him too by making him watch a video on phishing once a year for the rest of his life. But so that's a solution, but he still is going to use the same password for all of his websites. But then one of the services gets breached. So this can happen in a number of ways. Attacker gets root access to a server of one of the services that he's using. And it would probably usually only affect one password if he didn't reuse his password for all of them. So sometimes the passwords can just be saved in plain text if it's some random website written by the nephew of a business that he signed up for. Some big social media companies have been caught writing plain text passwords in their logs, so they get the parameters and they just log whatever parameters they get, and then that can be passwords. You can, even if you hash passwords, you can use an old algorithm like MD5. You can just Google every MD5 string basically and find out what it is. And then even with a more secure algorithm, if you don't salt the password, the attacker can use rainbow tables to get into them. And what are the solutions to this? Well, he uses there's the option of using a password manager, which is probably the best solution, and 2FA, the other kind of best solution to these problems that we've kind of settled on. But that creates a whole lot of friction. Like our lives have kind of turned into entering in 2FA codes all the time, at work all the time. And look, this guy's very stressed out. Half the letters aren't even real letters on these devices, so that's going to make it especially hard. Yeah, so it's a lot of friction, and maybe a question is, how many people here use password managers for personal use, not work use? Yeah, so it's like 60%, but this is like the best. This is the, we're developers, so we know this stuff a little bit. This is the best you're going to get at the moment, is 60% of people using password managers, and a lot of normal people don't. It's sort of a XKCD comic about this, about complexity with passwords, of creating a really hard password to remember. That's what our password rules will make us do. And then actually it's sort of brute force guessable, more brute force guessable than if you just have a really long password. Yeah, so that's the story of Mark. What's the moral of the story? The moral of the story is that passwords suck. And our solutions to try and fix passwords kind of also suck and create friction and kind of make them less useful, because we're always forgetting them, losing them, or reusing them. And passkeys are kind of the industry's attempt at solving this problem, or these problems. I guess it's more than one problem, as you've seen. When I say the industry, who I'm talking about is the FIDO Alliance. So it's an industry alliance made up of a bunch of big players. So it's got Apple, Google, Microsoft, Amazon, and a whole bunch of password managers, a whole lot of companies. And they develop open specifications which create passkeys. So the big important specification is called FIDO2, and the two parts of that are WebAuthn, which is the main thing we'll be interacting with as Ruby developers usually, and the other one is CTAP, which is kind of it's for cross-device communication to do with passkeys. So YubiKeys, or sometimes phones. We'll talk about that a bit more later. So they need to ask, how do we fix authentication? And one place to look is how developers have solved authentication. So when we use SSH, there is a way to use username and password with SSH, but the normal way we do it is with asymmetric cryptography. And kind of how it works, people online won't be able to see where I'm pointing. Wait, I can use the mouse. No, I can't. Okay, I'll just... So how it works is the client, this is the client here, they'll say, I want to authenticate with the server. The server will send a random message, and then the client will have a private key and a public key. The server only has the public key and never needs the private key. The client will hash the message with using the private key, and basically what the asymmetric cryptography means is the server can tell that what the client is returning was generated by this private key without actually having the private key, and they can't generate it themselves. Nobody can actually generate it from the same message unless they have this private key. Probably a lot of you know about this already, but in case you didn't. And the reason we send a random message each time is to stop replay attacks, which would be, if this was always the same, then I don't know, a third party could maybe, be on the same airport Wi-Fi as you or something, be able to see the packets you're sending and just resend the same thing and be able to authenticate. So this technique isn't going to work for your average normal person who isn't a developer. I don't know about you guys, but whenever I need to connect something with Git, I've been on this page about like 1,000 times, unfortunately, an embarrassing number of times. So we can't, if we can't, I'm glad people are nodding their heads there. I was just scared that it was just me that had to go to that page every time. Yeah, so this isn't going to work for normal people, so for non-developers. So kind of how it works is on your device, on your phone or laptop, the private key will be stored on dedicated components, and it's like it will be a system on a chip, which is basically really hard to get into, and basically if you want to access that private key, it's really hard to get into that chip without breaking the phone, and it's kind of set up into the device that you need to authenticate to access it. And then it's set up that you'll authenticate with your device, usually biometrics, to access that. So that kind of gives us two factors of authentication, that you have to A, have the device, and B, authenticate with the device to access the private key. So we're going to be interacting with browsers, being web devs. They will hit operating system APIs to make passkeys and then expose them to us Ruby devs with the WebAuthn protocol. And the interface is kind of built to be nice and seamless and easy to use for regular people, so you don't have to look like this lady. Examples of authenticators or passkey providers are iCloud Keychain or Google Password Managers, who are platform passkeys, and then the password managers like OnePass and LastPass. Those are also platform passkeys, and then YubiKeys use a cross-platform method. And also what you can do as well is you can sort of use your phone, if you have an Android or Apple, which is most people, use your phone as sort of like a YubiKey, and one of those open standards, CTAP, kind of provides a way for you to, provides a standard for how that works. So the WebAuthn protocol, it's a JavaScript API, so you have to have JavaScript to be able to use this. There's two main kind of important methods, which are navigator-credentials.create to create a new passkey, navigator.credentials.get, which you call to authenticate a passkey. And when you create it, so the client will create a private public key pair, and it gives you back the public key. It will give you back an ID for the credential, so the client actually generates an ID, which you'll need to keep on your server, and then an attestation object, which will sign the signature, and also that has methods for telling you what the device is, which we can talk about a little bit later. And then when you call credentials.get, it will give you the most important thing it gives you is the signature, but it does give you more than that. But the signature is the most important part. That's the part which tells you this person has the private key. This is the person that is trying to authenticate. On the server side, in the spec, it refers to the server as the relying party. And that's kind of what your service would be called. It needs to generate random challenges for passkey creation and authentication. It needs to have a relying party ID, which can be a subdomain or just a regular domain of your site. And then it will need to also create user handles. These are IDs that need to match your user, but they kind of have a set length in the spec. So you can't just use an integer that you have in your database already. You have to generate new ones. So for configuring it, there's a few things you can configure. I mentioned that there were platform passkeys and cross-platform passkeys before. You can kind of specify that only platforms like iOS are able to use it, you can specify that only any platform can use it, or you can say only cross-platform passkeys can be used, or you can say both. discoverable credentials versus non-discoverable credentials. Basically what that is in the old spec, you used to basically have to give the user or give the browser a list of the credentials that the user can use to log in. And kind of the problem with that is that you need to know who the user is at that point. So it'll be like, I enter my email in, then the server goes and checks, does Hugh have any passkeys? Then it'll say, oh, yes, he does. Here's a list of IDs that you're allowed to authenticate with them. So it kind of forces a two-step process. That's the old way, or I would say the old way of doing it. So they added discoverable credentials. And basically that will just say, if you have a passkey for this domain, please look for one and use it. And that's what it says to the OS or the browser. User verification, you can configure whether you want people to have to biometrically authenticate or enter a password in. The reason you would want to take that off is if you had users with old devices and they didn't have Face ID or something like that, and you wanted to make it smoother to use. And the other thing that you can kind of do is you can set it up so that when somebody clicks on a username email input, it will show the passkey UI if they have one. WebAuthn and Ruby. So the kind of like leading library, most popular library, recommended library is WebAuthn-Ruby, which is made by a consultancy called Setter Code. It will provide those server APIs for basically the things that I listed before, for generating random challenges, for creating user handles, and also probably the most important one is verifying the signatures, making sure that the responses are generated by the private keys. Mastodon and GitLab are two open source projects that you can look at the code for that use this. But they do only use it for their second factor of authentication. So, my argument would be that it's sort of two factors in ourself. You can use it to kind of skip two-factor authentication. So yeah, they don't give you an example of that, but there is this example of WebAuthn Rails demo app, which does kind of let you log straight into a service with it without going through a first step. But they do use non-discoverable credentials, so you have to enter your username in first, then use the passkey. So yeah, so there's not there's not many open source versions which are the way that I like, kind of thing. I'll say, yeah.
Today, GitLab announced that you can sign in with the passkey.
All right. Okay. Look at GitLab then. Sweet. So okay. So no, not as a two-factor kind of.
Sign in with a passkey.
Oh, cool. Oh, awesome.
You have to create an account first.
Yeah. You go. Yeah. Oh, okay. But cool. That's good to know. Oh, sweet. Okay. Ignore that third bullet point there. Third top level bullet point. So now I can show you some code. We'll see how this goes. So yeah, basically I tried to I should go git log. I tried to create something which was as little code changed as possible. Wait a sec, I got two branches here, and oh yeah, cool, I'm a main. Which would kind of show off what, from a vanilla Rails project, what you kind of would need to do to get web authentication going. So I've got this small project here. I'm actually just going to get the Rails server started now, and hopefully, oh hello, hopefully this should give us an error message, but it's a pending migration error message, so that's good. So, gonna run, cool, awesome. Yeah, so here we have, a super basic website where you can go in and click register. I'm gonna call myself, I'll just call myself Hugh, and then you can give your passkey a nickname, my passkey, and then this is kind of what it looks like. register, and then Touch ID in, and then now I'm logged in, and basically that has gone through that whole process that I talked about of checking the private key signature and everything. This is so basic; it doesn't have a log out feature, so I'm just gonna delete the session cookie and refresh, and then now this is kind of using the conditional mediation, it's called. So the thing where basically you have an autofill on this element, which might, in maybe the old, in password email app, this might be the email, and you can just click it there and it will have the suggestion passkey for this website, and I can just click that and then sign in. Hopefully. Okay, I might have messed something up there, but anyway, and then I also have another branch which kind of does it just with a button, which we might look at. I think this is the one that I want. I bought your changes. Oh, okay. Let's do a git reset -- hard. We don't care about this. Okay, let's do a refresh on this. Okay, cool. And then this one is just a button with sign in. Yeah, that's the one, ASDF1. Oh, just kidding. Sorry. It's Hugh. That's the problem. There we go. So I've made a bunch of passkeys for this, for my domain, localhost /3000, and I was using the wrong one. Maybe that's one thing to know about, is if it's kind of up to the user to delete their passkeys if they have deleted them on the server. There is an API in JavaScript where you can say, this passkey's been deleted, please remove it. It's not going to work anymore to the browser, and it will, it should remove it from your Apple passwords. I investigated it; it didn't do anything. So, I tried it once. Maybe that's I did only try it with Apple passwords, so maybe it actually works on Google Password Manager or something like that. Yeah, not much better. Yeah. But so basically, that is one thing to know, is that kind of both the user and the service will need to delete a passkey, kind of thing. Oh, so yeah, no stress. That gives me time to. Oh, cool, we're back. So yeah, I'll give you a look into what's happening here. Maybe the first thing we can look at is the registrations controller. So so we kind of have two main endpoints. New is just the view, so 3 endpoints. New is the view to kind of show the register page. Then we got this create endpoint. What that does is that's going to generate a challenge. So this part here, we're hitting the WebAuthn API, and we're saying, I want to create a challenge for this user who want to set up a passkey. We kind of give them the username they want to be called, and then oh yeah, that's right. And then we give them the WebAuthn ID. That's also, what that actually is the user handle I was referring to earlier. And it's basically a random string used for passkeys. It gets, in this app, it gets generated when the user is created, so we should already have one. And then this resident key required and require resident key true. These basically allow us to make a discoverable credential. The reason I put both there is because old devices will use this one, old browsers. And then user verification required. That's going to force people to biometrically log in when they create or authenticate with the passkey. And then as part of this as well, actually right at the top, this is an important one, we also create a user right at the top. And then if the user is valid, then we add to the session the challenge, and then we send back the create options. And so the create options will be a bunch of config, which I'll show you in a second. Then the second API, this is after, so the first step was to generate the challenge. Then from JavaScript, we talk to some APIs, create a new passkey, and then send it all back. And in this API, we're responding to that. So we create a WebAuthn credential object. And basically what that is going to do, that again, this is from the WebAuthn library. And then here is a really important part, WebAuthn credential.verify. So here we're kind of checking that that they're responding to the challenge that we generated, basically, that this is a legit response to what we generated. Then if that all goes well, we create a credential in our database. That's what we're doing here. And maybe this is kind of important for what we actually want to store on the server. As the most important two things are the external ID, which is the ID created on the client, and the public key, which we're going to use to verify signatures later on. If somebody has tried to respond to this challenge and they're using a different private key, the library will throw an error and you end up down here. I think those are the most important things for the authentication controller. And then the other one to look at is the sessions controller. So this is for when people are logging in. It's quite similar. So the first step is we create a challenge. Again, we're using the WebAuthn library here to make it. Again, we attach it to our session. And then again, there's a second callback after the passkey, after we've hit the browser API. And this will verify basically that they used that passkey. This will verify the signature that they've created with their private key. And again, it's called WebAuthn.verify. This is the most important method here, which will make sure that it's coming from the right place. I'll also give you a quick look at the JavaScript side. So what do we got here? I think it's called just WebAuthn.js. So kind of when it's loaded, we, let me delete this. When the page is loaded, we add an event listener to the sign-in button. And then when somebody clicks it, what we do is we go public key credential equals await navigator.get. Oh wait, first of all, we hit that first API, which is getting the challenge. So this bit here is we fetch the challenge from this session endpoint. And the challenge, we put in an object called credential options. And then we hit that navigator credentials.get. That will give us this public key credential options, which we send back to the server. So it's a really short amount of JavaScript code you do have to write. I mean, a lot of the stuff is just boilerplate, except application.json, content type application.json, which you probably already have somewhere else in your code base. So yeah, it's a small amount of JavaScript really to get it done, but maybe a blocker for some apps if you're trying to be really accessible is that you do need JavaScript to be able to use it. Yeah, that was a bit of a whirlwind tour, maybe, but hopefully it at least gives you the idea of what the code is like. And I have pushed this up to a public repo on GitHub, so you can properly look at it. And hopefully I didn't destroy anything important with that git reset at the start, so we'll find out after this. Maybe one more topic to look at is attestation. This is mainly for companies that want to make sure that the people are logging in with devices that that are secure, that keep these private keys in secure places. So that secure enclave that I mentioned earlier in like a iPhone, if you have a really cheap device, they won't have quite as secure a method of storage kind of thing. So this attestation is basically when you create a passkey, there's a method for being able to tell what device people use, and yeah, it's, we don't have time to go into it heaps, but basically, in summary, passkeys are resistant to brute force attacks, phishing. They're not shared with other services. They can only be used for each service because the domain will also be hashed as part of the process. They can't be based on personal information, like Spot 1983 with Mark. They're not a shared secret, so only the client has the private key. If somebody breaches a service, you can't do anything but with the information you get from their database. And they have a better UX. But maybe on the bad side of them, some issues. What if you lose your device? I'm going to say this is actually mainly a non-issue, because if you're, say, bought into Apple or Google ecosystem, if you lose your phone, but you have a laptop logged into Google Password Manager, you should still be able to use your Google passwords. Same with Apple. And the other thing is, with services, you can just make multiple passkeys. There's no limit on the number of passkeys you use. So if you have an Apple computer but a Google phone, you can make passwords on both platforms. Then if you lose one of them, you just log in with the other one. Maybe one big one is complexity. I'm over time on this talk, I think, and explaining passkeys to you, but I did waste a lot of time at the start with story time. But it's added complexity. It's more complicated than just 2 strings of username and password for a website. When we were working on it, we did find a few edge cases with browsers where they'll react differently to different config or throw different errors in different situations, and so it is quite maybe early-ish still, even though they've been working on this for 10 years or something, but in some ways it does still feel a little bit early for some browsers. I was showing you the passkey autofill, conditional mediation, that's called. There's issues with that where people kind of click on the user input, and then they will their password manager will jump to, hey, you've got a password saved on here. Do you want to use your password? And you kind of have to click 3 different places to actually use a passkey that you've got saved. And the other thing is, maybe you've made a passkey on the website, but you come up to this username password login, and the way to use a passkey is to click the top, the username, and then use your passkey. But you might come up to that and say, I don't know how to use my passkey that I've created. So Jordan's been fighting for a passkey button for Hatch for that reason. If you use BrowserStack for your browser testing, it's more expensive to have WebAuthn testing. And kind of AAGUIDs are kind of, those are IDs for devices basically, where you can kind of find out whether somebody's using iCloud or Google Password Manager. They're a little bit opaque, and it's a little bit inaccurate to try and use those. So it's hard to tell really what kind of, what service or platform they're using for a passkey. If you want further reading, probably the best resource that I found was this online free HTML book called A Tour of WebAuthn by Adam Langley. You can just like go on your phone right now and search it up, and yeah, it's got heaps of information. It will probably tell you everything that I've told you here, but a whole lot better. There's passkeys.dev, webauthn.wtf. There's that demo app that I mentioned earlier. This YouTube, which is going to suck to enter in. So Jordan, do we have a way to like share links to everybody? Yeah.
Put them in Slack, and I can send an email.
Yeah, okay. Great video, kind of introducing them. On that conditional mediation kind of form autofill, there's a really good web.dev article about that. yeah, that's probably everything I had. Thanks so much, everybody. Should I open it up for questions too? Yeah, any questions? Yeah.
When you're like a Ruby developer implementing this, are there any security foot guns that you could shoot yourself with? Or is it pretty easy to get right?
I think using that library, it's mostly pretty easy. Maybe one thing to double check that it won't automatically check for you is the client will generate, your server will generate a user handle and the client will generate a client ID, and kind of basically make sure that maybe you do need to add a check to make sure that they're trying to sign in as the right person, because they could add a different user handle but have a legitimate passkey for your service, but it would be a passkey owned by another user. Kind of thing. That is possible. So that's one check you need to do, which I didn't really go into there. Yeah, don't use that example app that I was showing you in production. But I think overall the library makes it quite easy, and that thing that I just mentioned to you then is probably like the only one thing that we kind of found that could be secure with my kind of when we were looking at our implementation. Like, yeah, I think the fact it's really hard to even try and make a test for to try to test it out with the wrong private key. It took ages for us to kind of manually test what if somebody does this. So yeah, I'd say it is quite easy to be secure as long as everything else is secure and you're using that library. Yeah, I'd say as long as you're not implementing it yourself and you are using that library. Yeah.
I think it's session storage, because the challenge is stored in the session. If you've got cookie-based sessions, it's probably bad.
That's very bad, yeah.
That's a big gun.
Yeah. And actually that reminds me of something that I forgot to put in. So it's good that I opened up for questions, is that we stored our challenges and sessions to start with, but we found race conditions. I think it's because, we found race conditions with it where different fetches, like different AJAX requests going to our server would override the session, and then sometimes people would basically on the first request they would create the challenge. It would be attached to their session. Then some other random AJAX request goes off, and then somehow there's a race condition and it deletes the session it deletes the challenge from the session, and then they don't have a challenge to try and authenticate to. So we ended up actually sending an ID for our challenge in that first request, which is something you can do. It's getting into the weeds of things, but yeah.
Thank you.
All right, thanks everybody. Thank you.